In the last video, we saw that atoms are made of three kinds of smaller particles. Protons in the nucleus, which are numerically equal to the atomic number. Neutrons also in the nucleus. And electrons around the outside in shells. This video looks at how protons, neutrons and electrons give an atom its overall mass. But first, do we weigh using atomic masses with the unit U, or with relative atomic masses without the unit? Because they're numerically the same, it doesn't matter. So we'll stick with relative atomic masses and drop the unit, making it simpler. Let's weigh them. Protons and neutrons each have a relative atomic mass of 1. But an electron is only 1/1836th in comparison. Wow! Protons and neutrons are the same mass as a hydrogen atom, but electrons weigh almost nothing in comparison, so we can ignore them. Over 99.9% of an atom's mass comes from its protons and neutrons. We can say that most of an atom's size comes from its electron shells, whereas most of its mass comes from its nucleus. Cool. Let's look inside a few atoms. Hydrogen's atomic number is 1, so its nucleus has only 1 proton, weighing 1. Its overall mass is also 1. So how many neutrons must hydrogen have in its nucleus? None. Its proton is the only particle in its nucleus. All of its mass is explained by this 1 proton. A helium atom has 2 protons, weighing 2, so they contribute 2 to the mass of the atom, but its overall mass is 4. How many neutrons must it have? Well, the total mass is 4, and this is made up of protons weighing 2, as well as the mass of the neutrons. The neutrons must weigh 2. So there must be 2 neutrons, because each weighs 1. Easy peasy. The neutrons are just the difference between the total mass and the number of protons, or the difference between the relative atomic mass and the atomic number. How about fluorine, atomic number 9? It's got 9 protons in its nucleus, and its total mass is 19. So it must have 10 neutrons in its nucleus. How about some heavier elements? How many neutrons does scandium have? Its atomic number is 21, and its relative atomic mass is 45. That tells us it's got 21 protons and 45 protons plus neutrons. The difference is 24. Scandium's got 24 neutrons in its nucleus. What about chromium? The difference between its relative atomic mass and its atomic number is 52 minus 24 equals 28 neutrons. Too easy. Now do the calculation for zinc. Do you get a strange answer? Zinc has a relative atomic mass of 65.4 and an atomic number of 30. It must have 65.4 minus 30 equals 35.4 neutrons. That doesn't make sense. How can there be 0.4 of a neutron? To make matters worse, most relative atomic masses are fractions like this. The next video gives us a surprising answer to solve this puzzle.